I just finished my ICU rotation, and interpreting ABGs like this was literally the bread and butter. So let's systematically break down how I approach any ABG. All right, step one, check the pH, which is normally between 7.35 and 7.45. So anything below that is going to be acidemia. Anything above that is going to be alkalemia. So in this case, we're in acidemia. For step two, we need to identify the primary disturbance. Is this a metabolic problem or a respiratory problem? In this case, we can look at our metabolic parameters like bicarb, which is normally in a range, but let's use the number 24. So anything below that is going to be low, anything above that is going to be high. But you can actually cheat and use this ABE, which is your actual base excess, which is anything between -2 and +2 normally. So anything below that is going to be metabolic acidosis. Anything above that is going to be metabolic alkalosis. So here we can clearly see we are in a metabolic acidosis. Now we can look at our PCO2 to see is there any compensation. Now, as I said, step three is to look for compensation. Now, if it's a primary metabolic disturbance, we're going to look for respiratory compensation. If it's a primary respiratory problem, we're going to look for a metabolic compensation. Now, in this case, we have a metabolic acidosis, so let's look for respiratory compensation, and we can actually use a really clever formula called Winter's formula, which is 1.5 times the bicarbonate plus 8 plus or minus 2. Now, what this formula gives us is an expected PCO2 if there's adequate compensation. So if we plug in the numbers, 1.5 times our bicarb 9 plus 8 plus or minus 2, we get 21.5 plus or minus 2. We can look here at our PCO2 and see that it's out of that range, so we don't have full compensation, but this PCO2 is not super high, so I'd say we have partial compensation. Now, step four is to calculate the anion gap, which is normally between 8 to 12. And how to calculate the anion gap is you take your cation, which is your sodium, 138, and you subtract that from the sum of your anions, which is your bicarb plus your chloride. So if we take 138 minus 111, we have 27. 27 is above 8 to 12, so that's going to be a high anion gap metabolic acidosis, also known as HAGMA. Now, this ABG was actually from a diabetic ketoacidosis case, and I want you to remember the other causes of HAGMA with left total knee replacement for lactate, toxins, ketones, and renal failure. And if you want to go one step further, you can do the delta ratio to see if this is a pure HAGMA, but let's leave that for today.